Section 7.1 is a review, something you did back in chapter 4 when we talked about antiderivatives. And we talked about the U-sub. We want to make sure that we get the U-sub out of the way and pick up the new techniques that we're going to learn. We have 5 techniques of integration. One of them is the U-sub. You need to get that out of the way. So, for a quick reminder in case you've forgotten about that, if you integrate a power function in which the power is any real number other than 1, then the integral of x to the n, to undo a derivative, since the derivative you bring the power down, subtract 1 from the power, to undo that, you add 1 to the power and you divide by that new power. So, glancing at example 1a, I'm looking at that and I'm thinking, wait a minute, that doesn't match. Well, I need a U-sub. What do you let U equal? You let U equal the inside of the parentheses, the inside of a radical, the argument of a log, the argument of an exponential, the denominator of a fraction. So you gotta glance at the problem and figure out, basically, if I let U equal a value, what would the U equal? So in this case, if I let U equal the inside of this radical, now after you do this enough times, you'll notice that if I take a derivative of that, that is 3x squared dx. So you notice I have a dx and I have an x squared. That's very good. You could be off by a constant. So what this means, this becomes the integral, and this part is really the u, and that's a cube root. That means it's 1/3. And the x squared dx is nothing more than a du, and the 1/3 I always drag up front because that's a constant. And the 1/3 you ignore. You would say, okay, let's see what this is. Add 1 to the power, divide by that, so you multiply by the reciprocal, the 3's cancel out, and you would say that is all over 4 raised to the 4/3 plus c, and what that would be is u. What was u? U was x cubed plus 2. So basically what you're asking yourself is, what do you take the derivative of to get this piece? Take a derivative of this and you will get that answer. So that's how the U-sub works. Let's look at example B. If I let U equal the inside of parentheses, the inside of a radical, the angle, the power, whatever they take in the log of. So in this case, if I let U equal natural log of x plus 3, and I'll start getting the hint, is this my du? Well, what's the derivative of this? Isn't that 1 over x dx? And what do you know? It matches identically. So if I replace my, if I replace my substitutions, that will be u to the 8, and dx over x is nothing more than du. So isn't that, add 1 to the power, divide by that? And if I get rid of u, pretty much I'm done. What was u? U was natural log of x plus 3 divided. And that's how we do these problems. If I look at part C, by now hopefully we're getting the hang of this. Well, let u equal the inside of a power function 2x squared minus 5. And if I take a derivative, that is 4x dx. So, if I look closely, I let the denominator be u. There's a radical there. And do you notice what x dx equal? You're off by a constant. That's a small price to pay. This is 1/4 the integral of u to the negative 1/2 du. Add 1 to the power, divide by that. That's u to the 1/2. When you divide by 1/2, you end up multiplying by the reciprocal. So that's really 1/2 the square root of u plus c. And don't forget, you always need to go back to x. What was u? U was 2x squared minus 5. And that's pretty much it. Well, I have some more examples. Few more to go. Here, I'm glancing at this. I'm trying to figure out, okay, how does it work? Well, the inside of a power function. Now, I start thinking ahead, a bit ahead. That is, if I let u equal the sine, would this be my du? That's something you really want to start looking at. So you don't have to actually do it. You could think about it. Well, yeah, if I let u equal the sine of x, the inside of the power function, obviously du will be the cosine of x dx. So this becomes the integral, and let's see. My sine is u to the 5th, and a cosine of x dx is nothing more than a du. Wouldn't that be u to the 6th divided by 6 plus c? And if I substitute what u was my sine of x, and there it is. Again, you could take a derivative of your answer. You should get the original integrand. And if I tackle this problem, well, I have two options. I could let u equal secant. Derivative of that will be secant tangent. Well, there's a tangent squared that doesn't work. Or I could let u equal tangent. Du will be secant squared. That'll work. So that's kind of what you start thinking. Worst case scenario, you try both cases. One of them will work. If I let u equal the tangent of t, the inside of this power function, du is secant squared of t dt, which means that's my du right there. That's perfect. That's the integral. The blue is my du, and there it is. And if I put a u in there, that will be u squared. And wouldn't that be add 1 to the power, divide by that, u cubed over 3 plus c? And what was u? U was tangent of t. And there it is. I'm glancing at this and I'm thinking, okay, I have two radicals. I wonder how that works. Well, let's see. If I let u equal 1 minus x squared, du will be negative 2x dx. That's definitely not this. That didn't work. But if I let u equal arc sine of x plus 4, du will be 1 over, there it is, it works. If I let u equal the inverse sine of x plus 4, the derivative of that will be 1 over the square root of 1 minus x squared dx. So what do I notice? That becomes u to the 1/3, because cube root I could write it as a power function, and the x over square root of 1 plus x squared becomes a du. Isn't that simply add 1 to the power and divide by that? If you add 1 to 1/3, isn't that 4/3 and divide by it? And don't forget, I don't want the answer in terms of u. Oops. I want the answer in terms of what u equals, which is inverse sine of x plus 4. And that's pretty much it. How about that problem? Well, same deal. If I let u equal the inside of a power function, du is e to the 3x times 3 dx. So this is my integral. I kind of put this right there. That is u to the 20th. And e to the 3x dx is really du divided by 3. And that would be 1/3. Isn't that simply now a power function? Add 1 to the power. Divide by that. And what was u? Again, you always have to go back. My u was e to the 3x plus 5. Of course, you could multiply those. Probably the back of the book will has e to the 3x plus c to the 21 over 63 plus c. That's the same thing. If I look at that second example, this is a definite integral. What am I going to let u equal? Well, it's obvious. If I let u equal natural log of x, du is 1 over x dx. If I let u equal natural log of x, du is 1 over x dx. So, there's my u. And du. Now, something you should start doing. You could go back to x and use the 1 and the e, but since I'm going to du, I could change the limits on the integral. If I put a 1 right there for x, because if this is dx, that's x equal. If this is dx, this is x equal to x equal. If this is du, now I want u to equal to the top. Take x equal 1. Natural log of 1 is 0. That's the bottom limit. If I take the top limit, or the upper limit, put an e in there, y will equal natural log of e is 1. This would be integrate u squared over 2, evaluated from 0 to 1. Throw the 1 in, that's 1/2 minus 0, which is 1/2. So if I have a definite integral, and in case you've forgotten, definite integral means I have the limits on the integral. The integral is given from a value to another. I should change the limits on the integral whenever I change the variable. That'll save me time in the long run. You don't have to do that. You could go back to x and use it accordingly. That turns out to be the same, but it would be easier and save yourself some steps if you actually learn this and start applying it. Same deal on I, the last example. This is a definite integral. When you say, I'm integrating this with respect to x, what you're saying from x equal 1 to x equal 10. So I'm going to let u equal x plus 1, the inside of a radical or a power function. Du is, the derivative of that is simply dx. So this is the integral of the square root of u dx would be du. Now, I should change the limits on the integral this way. I don't have to go back. That is, if x equals 0, u will equal 1. And if x equal 8, 8 plus 1, that will run to 9. Now I don't need to go back to x. You can only do that if you have a definite integral. This is u to the 1/2, right? Add 1 to the power. Divide by that. Evaluate that from 1 to 9. That is 2/3 times the square root of 9 cubed minus the square root of 1 cubed That is 2/3. Square root of 9 is 3 cubed, that's 27. Square root of 1 is 1 cubed, that is 1. So that is 2/3 times 26. That is really 52 divided by 3. And that would be it for this section.